how to derive the shear equation, and how to write down the shear equation without derivation also. So now we will see how to analyze the rigid jointed frame by slope deflection method. The question is, analyze the frame as shown in figure by slope deflection method and draw the bending moment diagram. So first thing is, by seeing this figure, we have to identify whether this frame is subjected to sway or not. So already we have seen lot of conditions for reasons for sway. The first condition is the loading is unsymmetrical. The load is unsymmetrical. So now coming to this load, the load is symmetrical only because this is a UDL load. It is acting entire length of the beam. And second one is boundary condition. So the boundary condition is also same. Okay. And third one is unsymmetrical shape. Yes, it is definitely unsymmetrical shape only. So about this vertical axis, so this is different shape and this is different shape because the height of the column is different here. Okay, so this type of frame subjected to sway only. Another one more is horizontal load is acting. If the horizontal load is acting, it will undergo sway, and the moment of inertia, that I is different. In this column is 2I, in this column is 1.5. Okay. So this frame is subjected to sway due to three reasons. One is unsymmetrical shape, another one is horizontal load is acting, another one is different moment of inertia of the column. Okay. So now the first step is find out the fixed end moments. So first we have to assume, so all the spans are rigidly fixed. Okay, so we have to find out the fixed end moments. Okay, so here coming to this one, span AB, M of AB means fixed end moment at A of the member AB. This is left side. So always left side anti-clockwise moment. Okay, already we know the formula. So here the load is acting at the center of the span AB. So the formula is minus WL by 8. Minus WL by 8. Now coming to FBA, end moment, sorry, not end moment, fixed end moment at B of the member BA. Okay, so here this is the right side of this span AB. Always right side, positive sign, positive WL by 8. Okay, always fixed end moment producing negative bending moment, that is hogging bending moment. Hogging bending moment means, so left side is anti-clockwise direction and right side is clockwise direction. Okay, so now so here W equal to 8 kilonewton. W equal to 8 kilonewton. L means length of the span AB, that is 3 meter. L equal to 3 meter divided by 8. If you substitute these values, we can get minus 3 kilonewton meter. Minus 3 kilonewton meter. Here also plus 3 kilonewton meter. Now coming to the span BC. Okay, so M of BC, that is left side moment. This is left side, this is right side. So for the left side anti-clockwise moment is, the formula is always minus sign only. So this span BC is subjected to UDL load. For this loading case, the formula is minus WL square by 12. Minus WL square by 12. So now coming to MFCB, here C, fixed end moment at C of the member CB. Okay, so right side same formula but plus sign, WL squared by 12. Okay, so here the magnitude of the UDL load, okay, is acting over the span BC, that is 9 kilonewton per meter. Here L equal to the length of the span BC, that is 2 meter, 2 square divided by 2, 12. Okay, the answer is minus 3, and coming to here MFCB equal to plus 3. The unit is kilonewton meter. Here also kilonewton meter. Okay, the first step is fixed end moment. Okay, so next one is we have to write down the slope deflection equation. Okay, here unknowns are 3. One is theta B, another one is theta C, third one is delta. So now coming to slope deflection equation. Slope deflection equation. Each span we can write 2 equation. One is MAB. Already we know that how to write the slope deflection equation. That is some fixed end moment MFAB plus 2EI by L. 2EI divided by L. Here L equal to length of the span AB only. Okay. And I also moment of inertia of the respective section AB. Okay. Into 2 theta A plus theta B minus 3 delta by L. This is general equation. Okay. So as per given problem, end A is fixed support. So at the fixed support there is no rotation. So theta A equal to 0. So now substitute the corresponding values here. MFAB equal to minus 3 plus 2E. We know that I, a moment of inertia of the member AB is 2I. It is given in the problem. And length of the span is 2. Then theta B minus 3 delta divided by L. 3 delta by L. Here length equal to 3 meter. Okay, if you simplify this equation, we can get minus 3 plus 4EI divided by 3 theta B minus delta. This is equation number 1. This is equation number 1. So similarly we have to form the MBA equation. We have to write the slope deflection equation at the joint B, that is end moment at B of the member BA. Same formula M of AB, here M of BA. Instead of AB we have to write BA plus 2E I AB divided by LAB. So here 2 theta B plus theta A minus 3 delta by L. 3 delta by L. So we know that this value equal to 2I, and this term becomes 0 because end A is the fixed support. So L equal to 3 meter and this is also 3 meter. So now substitute all those values. The final equation is MVA equal to 3 plus 4EI divided by 3 into 2 theta B minus delta. This is equation number 2. Equation number 2. So now we have to write down the equation for BC, span BC. Okay, AB is completed. Now span BC, that is MBC equal to M of BC plus 2E IBC divided by LBC. Here 2 theta B plus theta C minus 3 delta divided by LBC. Okay. So M of BC also minus 3 and moment of inertia of the member BC equal to I only. Length of the span BC equal to 2 meter. 2 meter. This is also 2 meter. Okay. If you simplify this equation, we can get one equation, that is minus 3 plus EI. Okay. Then 2 theta B plus theta C. Okay. So this term won't come because this is the B member. For the B member there is no sway. So only the column member will undergo some sway. Okay. For the B member this term becomes 0 only. For the horizontal member. So that's it. This is equation number 3. This is equation number 3. So now write down another one equation for the span BC, that is MCB, okay, M of CB plus 2E ICB divided by LCB 2 theta C plus theta B minus 3 delta divided by LCB. Again this is horizontal member, this term won't come. Substitute all those values, we can get the answer, that is 3 plus EI 2 theta C plus theta B. That's it. This is equation number 4. This is equation number 4. So similarly we have to write down the equation for the span CD also. Now coming to span CD, that is M CD equal to M of CD plus 2 E I, here I equal to CD LCD. So this is vertical member, span CD is the vertical member, so the delta term will come here, that is 2 theta C then plus theta D minus 3 delta by LCD. Okay. So if you substitute all those values, M of CD is 0. I think there is no load on this span CD. There is no load on this span CD. So M of CD equal to 0. ICD equal to 1.5 times of I as per the given problem. And LCD equal to, that is 2 meter. LCD equal to 2 meter and this is also 2 meter. But coming to here at D, okay, D is fixed support, so there is no rotation at the fixed support, so theta D becomes 0. Now substitute the values, we can find out the answer, that is 1.5 times of EI 2 theta C minus 3 delta divided by 2. So this is equation number 5. So similarly for MDC equal to 1.5 times of EI theta C minus 3 delta divided by 2. This is equation number 6. So now using slope deflection equation, we formulated 6 equation. Okay. So here unknowns are, with respect to equation number 1 to 6, we can see 3 unknowns are there. One is theta B, another one is theta C, another one is delta. Our aim is we have to determine these 3 unknowns, theta B, theta C and delta, using joint equilibrium equation as well as the shear equation. So now we have to write down the joint equilibrium equation. And so for finding the unknowns, so we have to write the equilibrium equation. Joint equilibrium equation. Joint equilibrium equation. Joint equilibrium equation. So here unknown is theta B and theta C. So we have to write equilibrium equation So the given frame is, this is more height, no? So this is more height compared to this one. So this is B and this is C. Okay. So here the end moment is anti-clockwise. That is, sorry, this direction anti-clockwise, MAB. Here clockwise, MBA. And here anti-clockwise, MBC. And here MCB. And here anti-clockwise MCD, and here clockwise MDC. So two unknowns, one is here theta B, another one is theta C. Okay, we have to write the joint equilibrium equation here, then only we can find out the theta B, and another one more equation is here, then only we can find out the theta C. So now joint equilibrium equation at B equal to summation of moment about B equal to 0. Summation of moment about B equal to 0. So two moments are there. One is MBA is there, another one is MBC is there. So now MBA plus MBC equal to 0. Okay, this is one joint equilibrium equation. So already we have derived the slope deflection equation. We have formulated the slope deflection equation. I think this is equation number 2 and this is equation number 3. So substitute equation number 2 and 3 here. Okay. So now this is equation number 1, 2, 3, 4, 5, 6, 7. Okay. Substitute equation 2 and 3 here. So another joint equilibrium equation is at C. At C, that is summation of moment at C equal to 0. So MCB is there, MCD is there. See here MCB and MCD. So now MCB plus MCD equal to 0. So this is equation number 8. I think this is equation number 1, 2, 3. Equation number 4 and equation number 5. So already we have formulated the equation number 4 and 5. Substitute here. So 7th equation and 8th equation. So our unknowns are 3. So we want 3 equilibrium equation. One is 2 is joint equilibrium equation. Another one more is there. That is shear equation. Shear equation. So shear equation. Okay. So end moments here MAB plus MBA. Here any lateral load is acting. Yes, the lateral load is acting 8 kilonewton. Here the lateral load is acting 8 kilonewton. This is 8 kilonewton. Here 1.5. Okay, 1.5 meter distance from B. So MAB, MBA. This is MBA. Then minus of 8 into 1.5 divided by total height of the column is 3 meter. Now coming to this vertical member plus here MCD and MCD. MCD plus MDC. Here there is no load. Okay. So divide by the total height of the column is I think 2 meter. Okay. Minus summation of horizontal force. Only one load is acting here. So towards right means positive sign, positive 8 kilonewton. This is equal to 0. So this is equation number 9. Shear equation is nothing but summation of horizontal force equal to 0. Okay. So now we are having 3 equation. Okay, 3 equilibrium equation. One is at B, another one is at C, another one is shear equation, which means summation of horizontal force equal to 0. Okay, so 3 equation. Using this 3 equation, we can easily find out the unknowns. So substitute the corresponding values. That is MAB, MBA, MCD, MDC. Already we have derived or formulated in the slope deflection equation. So substitute all those equation here and find out the unknowns. So the unknown is delta equal to 1.42 divided by EA. Okay, and theta C equal to minus 0.044 divided by EA. Then theta B equal to 0.4148 divided by EA. If you substitute this equation from equation number 1, 2, 3, 4, 5, 6, 1 to 6, we can find out the n moments. Our aim is finding internal moments only, n moments only. The method is different. Method is different to find out the n moments. We can use slope deflection, moment distribution, Carney's method. Okay. We can use any one of the method to find out the n moments. So MAB, if you substitute this all three unknown values from equation number 1 to 6, we can find out these values. 4.34 kilonewton meter, MVA equal to 2.21 kilonewton meter, MVC equal to minus 2.21, same unit, MCB equal to 3.33 kilonewton meter, MCD equal to minus 3.33 kilonewton meter, MDC equal to minus 3.26 kilonewton meter. So at the joint, we have written joint equilibrium equation. No, that is at joint B, MBA, MBC equal to 0. See here, if you sum up these two value, we can get 0 value only. So coming to joint C, we have written like that MCB plus MCD equal to 0. No, so if you sum up this one, we can get the 0 value only. Okay, this is one of the check whether we found the correct value or not. We have determined correct value or not. Okay, so now we have to draw the combined bending moment diagram. Okay, so first simply supported bending moment. Simply supported bending moment. So here the span AB is, this is AB, BC, CD. AB is subjected to midpoint load. I think this is 8 kilonewton meter, 8 kilonewton. For simply supported bending moment, if the load is acting at the mid, the maximum bending moment under the load only, the formula is WL by 4. So it is the point load. So the diagram is straight line. Okay. So WL by 4 is 6. This is simply supported bending moment. That is sagging bending moment, positive bending moment. Now coming to the span BC, the BC is subjected to UDL load. So for the UDL load, the maximum bending moment formula is WL squared by 8. If you substitute, we can get the magnitude 4.5. The shape of the diagram is parabolic because it is subjected to UDL load. Okay. Here there is no load on the span CD. Okay, no need to calculate the simply supported bending moment because the load is 0. So now we have to mark the end moment here. Okay, so end moment MAB, the sign convention, left side anti-clockwise, right side clockwise moment means we have to draw above the baseline. We should draw above the baseline. Okay. So here this is the baseline. So coming to here, this is the baseline. So this is top. Okay. This is the bottom of the baseline. Coming to here, this is the top of the baseline, bottom of the baseline. So coming to here, this is top, this is bottom. Because if you rotate this beam like this, okay, it will go like this. So this is top and this one is bottom. Okay. So MAB, this is A, B, C, then D. MAB is minus 4.34. Minus means above the baseline. So this is minus 4.34. Minus 4.34. Next one MBA. MBA is plus 2.21. So right side. This is left, right, left side, right side. This is left side, then right side. So right side is MBA is 2.21 plus 2.21. Right side plus 2.21 means above the baseline. This is 4. This is plus 2.21. Connect the line. So next coming to BC, MBC is minus 2.21. Left side is minus mean above the baseline, minus 2.21. Now coming to MCB, MCB is plus 3.3. Right side plus means above the baseline. This is 2.21, 3.33. Now coming to MCD, MCD is minus 3.3. Left side minus means above the baseline. So this is minus 3.3. Now coming to here, MDC. MDC is minus sign. Right side is, we are getting the minus sign on the right side. But positive sign only we have to draw above the baseline. Otherwise, draw below the baseline. So this is the below the baseline. Here 3.26. Now connect the this one. Now shade it. This is negative. This is positive bending moment. This is negative. This is negative. This is positive bending moment. This is negative. This is positive and this is negative. Okay. So this is combined bending moment diagram. Combined hogging and sagging. Combined bending moment diagram. Bending moment diagram. That's all. Okay. So the main thing is, the first we have to find out the fixed in moment. General steps. Okay. First step is fixed in moment. And second one is slope deflection equation. If the end is fixed, there is no slope. So rotation equal to 0 only. Third one, we have to write the joint equilibrium equation. Next, fourth one is, if it is frame is subjected to sway, means we have to write shear equation, otherwise no need. Okay, write down the shear equation. After that, finding the unknowns, then substitute this unknown into slope deflection equation and find out the final end moments. After finding the final end moments, find out the simply supported bending moment, then draw the combined bending moment diagram. So I have completed the slope deflection method. Already we have seen the continuous beam and continuous beam with the settlement of support. Now rigid jointed frame with sway I have completed. Rigid jointed frame without sway, similar to the continuous beam only. Thank you.